All right, welcome to Online Study for You. Welcome to the new video. My name is Ankan, and in this video, we are going to discuss the TCS NQT questions of today, which is 4th October. We are going to discuss the morning shift questions, right? So, I guess both of the questions were pretty easy. So, the first question was uh, write a program to check if a number is perfect or not. Okay. So, essentially, perfect number is a number where each of its factors, if you take the sum of all of its factors. So for example, if you consider a number 28 here, 28's factors are this 1 2 4 7 and 414, excluding the number itself. Okay. So if the sum of the if the sum of the factors of a number excluding itself, if you see that the sum is equal to the number itself, then we call that number a perfect number. Now this is um, very easy to solve. So, okay, so this was the second question, but first let's complete this first question. So, this was a question, which I did for the first time in my standard ninth in school. But so this question is in like comparatively, like it's so easy. So, okay, so if here you can take a number as an input. I've taken in number equal to 13. But if you are not happy with this, then you can simply take a number as an input. That won't change anything. Okay, you can also take the number as an input also. But at the end of the day, what we just need to do is we just need to check if I will simply take a loop from I to n by 2, and I will simply check that if I is a factor or not. If I is a factor, then I will simply take I'll simply take the sum of it, and if the sum is equal to a number, then we say that it is a perfect number or not. Now the I is going less than equal to num by 2 because the highest factor that that my number can have is up to 14, because I am excluding the number itself. So if I exclude the number itself, other than the number itself, the highest factor that the number can have is an n by 2. So it's all good to optimize it if we run the loop up to num by 2 times. Okay. So if you want to look at the time complexity of this approach, but first let's run the code. Okay, so let's say 13 is not a perfect number. Let's take a perfect number. So let's take 28. Yes, 28 is a perfect number. Okay, I guess 6 is also a perfect number. If I check with 6, 6 is also a perfect number. Okay, time complexity of this, if you just want the absolute time complexity, it's n by 2. Okay, O of n by 2. Okay, you can also write it as O of n, but okay, it's actually O of n by 2 because the loop is running only n by 2 times. Okay, so that was the first question. Okay, very easy. I had solved this in school standard class 9. But okay, coming to the second question. The second question is also very easy. Here you have, what you have is very simple. You have an input string here, okay? An input string here, which is separated by, of course, spaces. So it's a string consists of many words. What all I need to do is find the frequency of every word. Okay, so frequency of apple is present here 3 times. Okay, I didn't want that. Let's take this. Yeah, apple is present here, here, and here. Apple is present 3 times. Banana is present 2 times. Okay, banana is also present 3 times. So when I did this, I didn't do that. So let's actually, the input was not this, the one I tested. So okay. Yeah, okay. So yeah, so apple is 3 times, banana is 2 times, and orange is 1 times. Okay, so that was the input for which I had tested. But okay. Yeah. So yeah, so you just need to find out the frequency and its corresponding word here. Okay, as simple as that. You just need to find out the frequency and its corresponding word here. Okay, so word and frequency, word and frequency, word and frequency. This has to be in the same order in which they appear in your string. So first apple appears, then apple should be there. Then banana appears, banana should be there. Then orange appears, orange should be here. So that has to be the case. The order has to be maintained. Okay, so that is very, very important. The order has to be maintained. So if I discuss that question too, okay, the way okay, and I guess one more thing was there. If like if the input is not an alphabet, somewhere into in the input it is not an alphabet, then I guess you can also print invalid input. So the way you can do it, you can simply traverse the string. Once you have the string, you can simply traverse the string and check if if all of your characters are alphabets or not, okay, and spaces or not. Okay, so space is allowed, but other than space, no other alphabet is allowed here. Okay, so okay, so the way I have done it is very simple. First, you just get the string. Okay, you get the string. Then you check if it is valid or not. Valid means every character has to be an alphabet. So you just traverse through the string and check if any of your if any of your character is not an alphabet, and even not a space. So only space is allowed. So if it's not an alphabet, and if it's also not a space, because if it's not an alphabet, it can be a space. You can see spaces here, right, in between. So space is allowed. So if it's not an alphabet and also not a space, then you know there's something trouble with this. This might be some other data type. Okay, this might be a double or a integer. So in that case, immediately you return false. And if you are returning false, then here you can just print out invalid input, and your program will end here. Okay, invalid input. Otherwise, it returns true. So this if condition is not satisfied, we get here. Okay, here what I'm taking is I'm simply taking a string map, which will simply store. First would be my word, next would be my frequency of that particular word. This is the easiest implementation. Okay, then I have taken string stream. Okay, string stream I have explained in 2 of my previous YouTube videos. Okay, I've explained in 2 of my previous YouTube videos on this channel. So please check that out. So here what I'm doing is while SS greater than what? SS greater than what simply means I am dividing my stream into words, which means I also written it down for you. Yeah. So SS greater than what means I am every time you have SS extraction word, which is I'm getting it from my stream. So SS is my string stream. I'm getting it from the stream, and every time I do this, all I have is a word. Okay. So every time I do SS greater than what, which is a CN, we use this particular operator. This operator is called the extraction operator. So every time we do this, we will get a word, and every time we will get a word, it will be stored in our word string, which I have taken. So this word actually is used for storing a particular word. Okay, so this will store a particular word. Okay, so if this stores a particular word, then all I have to do is every time I'm getting a particular word, I just have to calculate and store my frequency here. I'll simply calculate my frequency here. Okay. Okay. And once I have my frequency, it's very easy. You just loop through the maps, and you know pair dot first would be this, and pair dot second would be this. So pair dot first would be the first of the pair. Pair dot second would be the second of the pair. So I'm printing the word first and then its corresponding frequency. Okay, that is exactly how it is. Okay, so yeah, that was the question. Okay, and yeah, so those were the solutions. I guess both of the solutions were pretty easy. Yeah. All right. So yeah, so if you still want me to run this, I guess I've already run it. So okay, apple, yeah, so this is going to be it. So apple is present 3 times, banana is present once, and orange is present twice, according to the input which I gave. Okay, now I was also looking for the same thing. You can also do it in Java as well, but you don't have string stream in Java. I've covered a lot on string streams, but you don't have it in Java. So in Java, if you have to do it, you have to take it as a complete string only. So this is the code in Java. Okay, hash maps is available. You, of course, we will need hash maps to calculate the frequency and store in Java. But other than that, what you need to do is you need to do it by next line only, which you're doing here, the get line. But after that, we don't have a stream. Okay. Okay. This is valid input part is exactly the same. So you check if it is an alphabet or if it is a space. Okay. If it is neither an alphabet, neither a space, it's invalid. Okay. So that part is exactly the same here, this function. So we are good. So this part is exactly the same. But here you have string here, okay? And okay, I've taken a hash map here, okay? So I don't have string stream. So instead of that, I guess we have taken a string tokenizer here. Okay, we have taken a string tokenizer, and it will simply break it into words. So we were doing the same thing here also. We were dividing my string stream into words, taking it word by word. Same thing. I have to do it using string tokenizer. Same thing. And here, what I'm simply going to do is I'm going to use it in my word count. So in my word count map, I'll simply put my word and its corresponding free frequency. Okay. I am going to put its word and its corresponding frequency. So once I have it in my map here, I'm simply going to print it. Okay. So in C++, we have pair.first, pair.second. In Java, we have the get key and the get value. So this is the key and this is the value. So first the word, then the value. Okay. So first the word and then the value means then its frequency. So if I paste it here and I run this, it also prints the same. Banana is present once, orange is present twice, apple is present thrice. Okay. Yeah. So yeah, so that is what the Java code is. You can have a look, and yeah, more or less the codes were pretty much the same. So that isn't difficult. So this part about isn't difficult considering you have already checked out my string stream videos. All right. Okay. So one thing to note here is that in case your order is not perfect here, because what we wanted is that we first wanted apple, then banana, then orange, as we have. So make sure instead of hash map, you can use a tree map here. So if you use a tree map here, then your order should be good, right? So that also can be done. Okay, if I run my program just again. So let me just enter it. Yeah, okay. So apple is present 3 times, banana is present once, orange is present twice. I would prefer using a tree map here to maintain the exact order, because in TCS compilers you usually don't know. You need to print like the exact output to get your get your answer to be correct. So yeah. So that was how you can do it in Java. And C++. I've already covered using string streams. Okay, string streams is something I had been covering a lot in this channel as well. So yeah, do check that out. And yeah, so I can move on to the next question. So I can also cover so I can also cover yesterday's TCS NQT. So let me just close this up. Or okay, let me keep it. So yeah, so this was yesterday's TCS NQT. So I guess this was TCS NQT. This was yesterday. So this was 3rd October. And this was the second shift. Okay, so this was the second shift. Okay, so TCS NQT 3rd October, the second shift. Okay. It had these two problems. So the first problem, I guess, was very easy. So here, I guess it had the length of train and a bridge. Both were 400 meters. So the length of the train was 400 meters. Length of the bridge was 400 meters. The train had to cover a distance of 400 meter. Okay. So how long will the train take to cross a bridge, given the train speed is that and the length of the train and the bridge is also given. So length of the train and bridge is 400 meters. So how long will it take for the train to cover the bridge of 400 meter? How long will it take given a speed? So I need to give my speed as a user input, and my program should give me the time. So time is equal to distance by speed, and so you're covering the length here. So the way is, if this is if this is the length of the train, and you have a bridge here, right? You have a bridge here. Let's do this a bit properly. So let's say you have a bridge here, so something like this, and you also have a train here. Okay. Now the length of the train is 400 meter. The length of the bridge is 400 meter. Okay. let's bring the bridge here. Absolutely. Okay. So whenever the train has to cover this bridge, the train has to cover its own distance, which is 400 meters plus the distance of the bridge, so which is 800 meters. Okay, so this is basic physics, I think, but okay, basic math. So because the train is traversing in this direction, it has to or not only cover the bridge, of course, it has to cover, but it also has to cover the entire train has to get off the bridge. Okay, when I'm saying the train has to go, has to cross the bridge, not only the 400-meter of the bridge has to be covered, but the entire 400-meter of the train has to cross the bridge. So you have to add 400 to that as well. Okay, so it's 800 meters. And given the speed, I guess the speed is being taken in kilometers per hour. So you need to convert that in meters per second. And then you can simply divide it by 800. It's very easy. So yeah, you're taking the speed in kilometers per hour. The total distance is 400 plus 400. So the kilometers per hour need to be converted into meter per second. So this is the conversion of kilometers per hour into meters per second. Once you have that, you simply divide the distance by your speed. Okay. So let's say if the speed is 18 kilometer per hour, so the speed in meter per second will be 5 meter per second. So 800 by 5 is 160 meters. So if I enter it, it should be 160 seconds. Okay, 160 seconds because I'm finding the time. Okay, 160 seconds. Okay, so this was the answer. And yeah, this is in C++. Java code will also be exactly same. It's just the input output, the basic Java syntax you guys know. That would be different. But again, the code has like 2 or 3 lines. Okay, so this is very easy. The second problem, I guess, so this is the first problem which I have found a bit interesting. So let's pull this down now. Yeah, so this is the second question I found. Okay, this is the first time I guess in NQT I found a question which is a little bit interesting. It's not tough, but a little bit interesting, where you have an day, you have a bigger day, you have to break it into two parts such that their average is same. So if you take up, okay, let's say you have 10 here, let's say you have 3 here. Okay, you have 3 here, and let's say you have, okay, okay, let's say you have 8 and 4 here, and let's say you have 6 here. Okay, let's say this is an array. I'm just taking an example of my kind. Okay, so let's say you divide this array along this, right? So the average of the single number is 6. The average of these two numbers is also 6, because 8 plus 4 by 2 is 12 by 2, which is also 6. So you have been able to successfully divide the array into two parts, which is into two sub-arrays, such that their average is equal. Okay, so this is a valid example. That is what we need to do. We actually need to go and manually try to divide the array into two parts, okay, such that their average is the same. Okay, so the way you can do this, I guess you can use mainly the brute force. I mean, you can use brute force, but so essentially what you need to do is you just need to calculate the sum, right? You just need to calculate. So essentially, if you look at this, so I mean, if you consider this as the left sum, if you consider this as the right sum, so if you want the left sums average of the left sum, so it'd be left sum by the number of elements in the left sum. Okay, so by number of left elements, this has to be equal to my right sum divided by number of right elements, right? This two has to be same. Now, one thing you know that, okay, if I denote my left sum as L, my right sum will be total sum minus of L. Yes or no? Because left sum plus right sum will be equal to the total sum, right? So, and my number, and if my number of left elements, if my number of left elements is, let's say, I, or let's say if it is X, then my number of right elements will be number of elements of the array. So I guess the total arrays, which is the size of the array size minus of x. So if you know this, okay, array size we usually define by n, so n minus x. So if you put it here, so L by number of left elements is x, that has to be equal to, right sum is total sum minus L divided by number of right elements, which is n minus x. So if you try to solve this, it would actually give you like, okay, so it is, so L multiplied by n minus x, this has to be equal to total sum minus L multiplied by x. Okay. So this is all we need to find out. So for every, so what we are going to do is we are going to traverse through the array, and at every point we are going to break it into left subarray, right subarray, and I'm going to put it in my formula and check if this formula is holding true or not. Like if this particular line, if this particular line is holding true or not. If this particular line is holding true, then we return true. And if my whole array, if I've traversed through my whole array and this particular line has never been true, then I have to return false. Okay. So I'll try to code this up. I haven't coded this. Let me just rub this up and I'll try to code this up. Okay. So, okay. Let's try to code this in C++ first, and then we are going to code, and then I guess I'm going to get the code for Java as well. Okay, so let's start with C++ first. All right, so I just wrote the code of this in C++. It's very easy. So what you just need to do it is, okay, I've done it like this. You enter the number of elements, then you take all the elements to store it in a vector. In C++, for Java, you can take an array or even a array list for that matter. And then you have a function called can split. Okay, if it can be split, you output yes. If it cannot be, you just output no. What this can split will do, okay, I have a function for calculating my sum of all the elements of my vector or array. So what this can split will do, it will simply it will just iterate through my array. Okay, iterate through my array and check. Okay, so let's say if it is 684 here, right? Okay, so first it will divide this. This is left, this is right. Is it possible? Yes or no? Okay. After that, what it is going to do is going to, let me copy it again, and let me copy it again. Okay. So this was the first step. Second step, it's going to go to the next iteration, and then it's going to check if this left is okay, and if this right is okay. So if the average of left and average of right is same or not, then it's going to do that, and it's going to take the entire array. Okay, on the right it is nothing, so it won't take it, and on the left it has everything. Okay, so this is how it will go on. We just loop through the array, and every step I'm partitioning my array into two halves, left half and right half, and checking their individual averages. So here you see that I'm just doing for I equal to 1 to n, and I have the left sum, which is 0 to I. So index number 0 to index number I, and here so if I have the left sum with me, which is 0 to I, if I have this left sum with me, then the right sum will be the total sum minus of left sum. Okay, total sum I have already calculated, so you just do total sum minus of left sum. Then you come and put it into the formula. If left sum into n minus x, if n minus x into left sum is equal to my total sum minus left sum into x. So that is total sum minus left sum is right sum into x. What is x? I here. Okay, so it is basically I have written in over here like this. I have written over here like this. So I have rotated this. So this part I have written here equal to control V. Okay, if total sum minus of left sum, which is right sum into I equal to left sum into n minus I. Right sum into I equal to left sum into n minus I. If this is true at any point of time, which means that if at any point of time here in these three steps here, if the array would have been greater, we would have even had more steps. If at any point of time I am able to divide my array into two halves, then you return true. And if your whole array you have traversed, the whole array and you haven't found anything where you can divide this array into two parts, then you return false. Okay, so this part is very, very easy. Okay, so yeah, if you want to run this, you can also check. I've tested previously with 684 because this is the example we took, right? 6, 8, 8 and 4 average is same. So enter number of elements 3 and you've taken 6, 8 and 4. This is printing yes. But if you take some arbitrary example like, let's say you take something like 3, 7 and 15, this will print no, because there is no such averages of two subarrays such that those two subaverages sum is same. Okay. All right. So these were the questions from yesterday's TCS NQT 3rd October second shift, and earlier I had covered today's first shift. All right. I'll meet you in the next video with further concepts. Thank you everyone for watching. I hope you have understood this, and if you have any questions, please write it down in the YouTube comments below. All right. Thank you everyone.